What's up, everybody? Today we're going to be doing USACO 2019 January bronze level, problem 2, sleepy cow sorting. Let's read it together. Farmer John is attempting to sort his N cows. That's just how many cows he has, between 1 and 100. We don't know how many cows he has. It might be 1, it might be 2, it might be 50, it might be 100. It's not going to be more than 100, but we have at least 1 cow. Conveniently numbered 1 through N. Okay, so if you can imagine, like we've got, I'm just going to real quick, cow, and then another cow. It's like Minecraft cows. Cows. Okay, so I got cow number 1, cow number 2. So the cows have little numbers on them. Okay, numbered 1 through N, N being whatever the last number is. So if there's 100 cows, the last cow will be cow number 100. If there's only 5 cows, then N is going to be 5. He's trying to sort his cows before they head out to pastures for breakfast. So the cows are about to go get breakfast. They're standing around, presumably not in order, and we have to put them in order. Currently, the cows are standing in a line in the order P1, P2, P3, up to Pn. Now, these can be a little intimidating at first, but this is actually important information. All they're doing is they're saying that the numbers of the positions where the cows are located are labeled as like P1, P2, and so forth, P3, etc. So the cows aren't necessarily in order. So for example, the cow numbered 2 might be in the P1's position. The cow in position 2 might be cow number 3. The cow in P3, cow horns, might be cow number 1. But the positions are going to be static. So the first cow is always going to be called the position 1 cow. And Farmer John is standing in front of the cow in P1. So Farmer John, let me just draw him here, farmer hat. Here we go. All right, so Farmer John is standing in front of the cow that's in position 1. In my example here, that's cow number 2. He wants to reorder the cows so that they're in the order 1, 2, 3, up to N. Okay, so he just wants to put them in order with cow 1 next to Farmer John. Okay, so we want to get the cows so that cow 1 is in position 1, cow 2 is in position 2, cow 3 is in position 3, and so forth. The cows are a bit sleepy today. So at any point in time, the only cow who is paying attention to Farmer John's instructions is the cow directly facing Farmer John. Let's think about what that means. The cow directly facing Farmer John is this cow right here. That's the one that's right next to Farmer John. He's the only one that is listening to instructions. So Farmer John is going to try to get these cows sorted by issuing instructions to the cow in position 1. In one time step, which is just like in one turn, essentially, if you were playing like a board game, like one move. In one time step, he can instruct this cow to move K paces down the line. Okay, let me clean this up a little bit here. So we're gonna take a cow. I'm gonna do, let's do P1, P1, P2, and P3. Let's say like I have cow 2 is standing here, and then cow 1, and then cow 3. Okay, so he's going to instruct this cow to move K paces down the line for any K in the range of 1 to N minus 1. That's another important thing to note, that the largest number of paces that K can be is going to be N minus 1. So K, just about this variable K, K is just some unknown number. As we're solving the problem, K is going to have different values. The value could be 1 because the cow can move 1 step back. The value could be 2 because he could move 2 steps back. But in this case, the value of K could not be 3 because if they were to go 3rd step back, there's no spot there. That's an empty space. So the furthest they can go back is N minus 1. The K cows whom she passes will amble forward. Fine, okay. So if we're moving the cow in position 1 back, so for example, if 2 comes out of line, 2 is gonna move back, say 2 moves back 1 space, then the K cows that she passes, which would be 1 cow, will move forward, which would move 1 forward into this position right here. If the K was 2, that would mean the cow's gonna move 2 steps back. That would mean that 2 cows are gonna move forward. And then the 3 would end up here, and then the back would be empty. Now, whether the K is 1 or whether the K is 2, what's gonna happen is 2 is gonna come out of line and move some number of steps back, and that same number of cows is gonna move forward, which is gonna leave an empty space for cow 2 to then drop into the line. Okay. And then making room for her to insert herself into the line after them. Right, so the cows are gonna amble forward and then she'll have space to insert. For example, suppose that N equals 4. So say like we have N equals 4, so we've got 4 cows, and they're starting off in the following order. So here's Farmer John at the front, Farmer John, And then we have cows 4, 3, 2, and 1. 4, 3, 2, and 1. The only cow paying attention to Farmer John is cow 4, right? Because cow 4 is in position 1, as we talked about earlier. If he instructs her to move 2 paces down the line, the order will subsequently look like this. So if we move 2 paces down the line, that's going to be 1, 2. 4 is going to try to insert into this location right here. 2 cows are going to move forward because k is equals 2. So 3 is going to move forward into that spot where the 4 used to be. 2 is going to move backward into that spot where the 3 used to be. And now cow 4 can insert into the line. And then it produces the order 3, 2, 4, 1, which we've just figured out 3, 2, 4, 1. It's a good time to mention, if you don't have paper pencil by your desk, I recommend always keeping paper pencil by your desk. As you're reading through these problems, you probably are going to want to do something very similar to what I'm doing here, which is to just write different examples out. As I'm reading this problem, I'm writing out basically an example of this. I'm writing out the positions, I'm writing out the cow numbers, I'm looking at different orders. I'm actually drawing lines to simulate like, okay, well, when this cow moves back k steps and these cows move forward, what does that mean? As I'm thinking about this, I'm starting to understand how the problem is going to go together. This is a very important step. And then once you get down to the example, you should already have a pretty good idea of how it's going to work. And this should be what you expect it to be. If that's working out to be the same, then that's great. That means you understood the setup. If you follow the example and get a different result, then it's probably a good idea to go back and reread this. A lot of times people will misunderstand something in the initial setup, and then they'll spend an hour coding a problem answering a question that wasn't even being asked. So it's very important to make sure that your understanding fits with these examples, if they're provided, and they usually are. Now the only cow paying attention to Farmer John is cow number 3, right? Because 3 is now at the front. So in the second time step, he can give cow 3 an instruction, and so forth until the cows are sorted. Farmer John is eager to complete the sorting, so he can go back to the farmhouse for his own breakfast. Help him find the minimum number of time steps required in order to sort the cows. So minimum number. That's important because we're not trying to just come up with some solution. We're trying to come up with the best solution. Now, this is another important thing to point out. A lot of times in these problems, they'll have a setup where you might be thinking like, wow, how am I going to do that? But in this problem, we don't actually have to sort the cows. This is a really important thing to note. What they're asking you for is the minimum number of time steps, not what those steps are, not what each stage of the sort is going to be. We don't actually have to do any solving in order to do this. We just have to figure out what is the minimum number of steps. And if we can understand the mechanics of how these cows are moving around, we can figure that out without having to sort them. So let's look at real quick at the input and output format. The input format, in this case, it's going to be a file. You got to watch for this. Sometimes it's from a file. Sometimes, more recently, they've switched it so it's from the console. So the file will be sleepy n. The first line of input contains n. This is a example right here. That's 4, which means n equals 4. So there's going to be 4 cows. The second line contains n. That's how many? 4. Space separated integers, p1, 2, 3, up to n, indicating the starting order of the cows. Now, if you're not familiar with this format, basically what's going to happen is there's going to be a lot of different tests with a lot of different orderings of cows. This example is with a 4, and with 4 cows, the initial order is 1, 2, 4, and 3. But they're going to have examples where there's 1 cow. They're going to have examples where there's 100 cows. They're going to have all sorts of different combinations. So your code needs to be able to work with all sorts of different situations. And you just need to keep that in mind as you're writing your code. So let's look at how these different orderings are going to break down, like what the different number patterns are going to do, and see if we can figure out a pattern that we can find here that'll help us keep track of what our expectations are. So I wrote down a couple number sets here. Let's try 2, 4, 1, 3, 5, 6. Okay, so we can kind of just eyeball this one. So the 2 here probably is going to want to go between the 1 and the 3. And the 4 here is probably going to want to go between the 3 and the 5. And rather than having them move up, I'm just going to draw arrows to show where they're going to go. You can just kind of imagine that they're all shifting forward. If I were to do that, then the 2 would end up here, and the 4 would end up here, and I'd have 1, 2, 3, 4, 5, 6. So that would be done in 2 moves. In that case, what's happened is these 2 cows in the front, 2 and 4, have inserted themselves into the ordering back here, 1, 3, 5, and 6. Let's do the next order. I have 2, 4, 7, 3, 1, 5, 6. Okay, so I did this one on purpose to kind of demonstrate that we can't always tell immediately where things are going to go. Ideally, this 2 here is going to have to go between the 1 and the 5. And that makes sense because 2 fits between 1 and 5. The 4 is going to go between the 2 and the 5. 7 is going to go to the very end. And the 3 is going to go between the 2 and the 4. So again, 2, 4, 7, and 3 had to get inserted into the set of 1, 5, and 6. And you might already have noticed a pattern, but we're going to do a couple more number sets. Let's do 2, 1, 3, 5, 4, 6. Now, this one's a trick question. You have to watch for this. If 2 was to insert themselves in front of the 1 here, then I would have 1, 2, 3, but these numbers are still out of order. Now, this is important to note because these guys back here, if they're out of order and I start moving cows around in the front here, these guys don't move. So even though I got the 2 inserted into the correct location, if I move the 2 between the 1 and the 3 here, I didn't fix this yet. So let's try and dig into why that one didn't work. Because up until now, we've been able to just kind of see where the cow should go, but this time it didn't work. The reason why it didn't work is because these guys are not ready to start having cows inserted into them. And this is not part of this set. So what's the distinguishing factor here? The distinguishing factor is this 5 and 4 being out of order. Because the 5 and the 4 are out of order, I can't fix the front because until I get this 5 moved between the 4 and the 6, fixing the front would be meaningless. Because even if I fix the 2, let me back this up here. Even if I were to put the 2 between the 1 and the 3, so 2 comes out, the 1 moves forward, the 2 drops in, then I'm going to have to move the 1 anyway. And the 1's going to have to go back here between the 5 and the 4. So the reason why this has happened and what we need to watch out for is what's in order back here and what's in order up here. Let's look at a couple more examples and we'll come back to this one. I think it'll make sense why this one is doing what it's doing. If I were to have 6, 1, 2, 3, 4, 5. This is a simple one because 1, 2, 3, 4, 5 is already in order. 6 just needs to go to the back. If I were to have 6, 5, 1, 2, 3, 4, 6 could go to the back. 5 could go between the 6 and the 5, 6 and the 4. And then once again, this would be 1, 2, 3, 4, 5, 6. Oops, try that again. Okay, if I were to have 2, 3, 4, 5, 6, 1. Okay, now this one should be a little bit more of a giveaway as to what's going on here. In order to solve this, I have to get the 1 up to the front, which means that all these numbers are going to have to go behind the 1, which means those are all the numbers I'm going to have to move. And the reason why, once again, is because if I were to try and have that front set be these guys right here and the back set be 6, 1, the back set's out of order. So the solution to this problem is that you have to try and figure out what of the cows towards the end are in increasing order, and then use that as your location where you're going to be inserting the cows that are on the left. Let's look at another example. Let's do 3, 2, 4, 5, 6, 1. Once again, same situation. Regardless of the ordering here, this 1 needs to make it to the front, which means those 5 need to be inserted. When those 5 are inserted, you can insert them into whatever location they need to be in the back, which means the order of the front doesn't actually matter at all. The only thing that matters is the ordering of the back. So let's go back to that very first problem. 2, 4, 1, 3, 5, 6. Now, if you remember this one, I had to place the 2 here and I had to place the 4 here to get that one solved. The way that we can determine this is if you start at the end with the 6, look at the 1 directly next to it, which in this case is the 5. If these are in increasing order, if the 5 is smaller than the 6, that means that we can include this in our set of on the right side that are already sorted. That continues. The 3 also, even though it's skipping 1 digit, these are all in increasing order, and also the 1. This is the line that divides them right here. The line between the 4 and the 1, because from the 1, this is increasing going up to the 4. But everything else, 6 to 5, 5 to 3, 3 to 1 has been decreasing. As soon as it increases, that means that everything to the left is, regardless of the order, is going to have to be inserted into the items in the right. And the location of the 1 doesn't actually even really matter. Wherever the 1 is, even if the 1 is towards the front here, for example, if I switch the 1 and the 4, the line is still here. So I don't have to go to the 1. The 1's not connected to the answer. It's just how long are these decreasing until we hit one that isn't decreasing, and those numbers get inserted here. So when you go to actually write the code, essentially what you're doing for this is you're starting on the last number, and you have some sort of a loop that's going to keep checking if the number to the left of it is smaller. Keep working its way back until you hit a situation where that's not the case. Whatever index you were at, in this case, this is index 0 if you're using an array, index 1, index 2, index 3, index 4, index 5. Wherever that stopping line is, the number of moves that you need to make is going to be equal to the index of the last one that is found. The other way to look at it is you can say, once you find the final index, however many items there are over here would be essentially whatever the last index is, plus 1, 2 plus 1 equals 3. Either way you want to look at it though, this number right here, however many items there are over on the left side, that's how many steps it's going to take. And if we check back on the main problem, we'll confirm that with the sample input here. 1, 2, 4, 3. If I start from the back here, I didn't even get 1. This is the only number that's in place, which means this is the number that we're going to have as our where we're going to be inserting into. And these are the numbers that need to get inserted. In this case, the 1's going to go here, the 2's going to go here, and the 4 will go at the back. And that'll be 3 moves. All right, good luck coding it, and I'll talk to you on the next one.